So for this problem, we're going to find the second derivative of this function. Now, to do that, we have a couple options. I always call it algebra now or algebra later. So we can start with just recognizing, this is the most common way students see this problem, is that we have a quotient rule. We have something with x divided by something with x, and we'll go with that. This would be the algebra later approach. So if we start with this and we just do the derivative using quotient rule, now we're not going to forget it's low d high, so we take the low times the derivative of the high, the numerator, so that'd be negative 10x plus 1, minus the high, or the numerator, times the derivative of the low, all over the square of what's below. And now we need to do a little bit of algebra. So we're going to go ahead and distribute, because to get that second derivative, we're going to want this as clean as possible. So we're going to distribute that x. We're also going to take this negative sign and distribute this through, resulting in negative 10x squared plus x plus 5x squared minus x minus 6 all over x squared. Now, of course, we're going to want to combine like terms before we take our next derivative, just to make things a little simpler. So I'm going to go ahead and look for my x squareds and combine those, resulting in negative 5x squared. I'm going to look for my x to the first terms, my linear terms, and those actually subtract to 0. And then finally, my constant terms, I only have one of them, negative 6. So minus 6 divided by x squared. And now with this as simple as possible, we'll go ahead and do the second derivative. Once again, using quotient rule. So low, the denominator, d high, the numerator, derivative of the numerator, which would be negative 10x, minus the high, so the numerator, times the derivative of the low, all over the square of what's below. And x squared squared, we know the powers, when we have a power to a power, that it's multiplication, so that makes it x to the fourth. Then one final simplification step, well, maybe two. That would make negative 10x cubed. Take this, distribute this negative through. We're also going to distribute the 2x through, resulting in, let's see, that'd be positive 10x cubed. And then here we're going to have a positive 12x all over x to the fourth. And now we're almost done. We're going to go ahead and realize that our x cubes, those terms, subtract to 0. And then finally, we had a little bit of simplification luck, because now we have a monomial divided by a monomial. So the x divides with x to the fourth, resulting in the second derivative being 12 over x cubed. Now, the other technique, exact same idea, but not doing algebra later, we're going to do algebra first, means we can look at this, and I would always highly recommend, it's going to be a great technique for later in the class when we get to antiderivatives, to not bring this x up as a multiplication. This will work. This works 100% of the time. It is mathematically legal. Whoops, that was sloppy. There we go. This is mathematically legal to rewrite this as x to the negative 1, then distribute it through. But I would much prefer, because it's going to be an antiderivative technique, that I see you rewrite this as 3 fractions. Right? So we're going to split this up into 3 fractions. Now we can simplify each fraction individually. So x squared divided by x results in negative 5x. X divided by x makes 1. And we can rewrite this for derivatives as 6x to the negative 1. This is going to bother me if it's not all in blue. Okay, much better. Now we can take the derivative. And the derivative in this form will be much simpler because it's all power rules. So this will be the derivative of negative 5x is negative 5. Derivative of 1 is 0. Negative 1 for power rule makes negative 6 x to the negative 2. And no algebra simplification needed. We can roll right into our second derivative. The second derivative of negative 5, negative 5 would be 0. The negative 2 comes out to the front, making it 12 x to the negative third, which we could then rewrite as 12 divided by x cubed, resulting in the same answer we had previously. All right, I hope that helps.